Lesson 42, Part 1 is recognizing patterns for equations with two variables. Go ahead and get your notes ready. Push play when you're ready to begin. All right, well, let's start with we do number 1. And you're going to want to copy down this chart thing like this, like the way I've copied it down. And so here we have the x, and it equals y. Okay, sorry, I had to move my dog. She was making all kinds of noise. Okay, so here you have the x and y. And what we're saying is when x equals this, and we do whatever magic we're going to do in here, then y will equal that. And for this lesson, what we have to figure out is what magic is going on here. What is the equation that is being used to turn this into this? So we have y equals, and I'll put the equal sign here, some sort of equation that involves x. So what we have to do, and this is really starts off being very difficult, but it becomes easier. You start to see things more quickly. So we just have to go back to when we worked on patterns when you were in the younger grades. What were some of the patterns that you see as we go through this? So what can I do to 3 to make him become a 7? It's going upward, so maybe some addition or some multiplication or something, because addition and multiplication make numbers go higher. So 3 times 2 is 6, and if you add one more is 7, or 3 plus 4 is 7. So it could be one of those combinations. If it could be that, and I'll just put a note to myself. Okay, so there's my note off to the side that could be that this math happened. 3 times 2 is 6, plus one more gave me 7. Or maybe I did 3, if x is 3, plus 4. So there's some possibilities. I'm going to look at the next one. If x is 4 in this case, and I do 4 times 2, that's 8, plus one more is 9. That's not going to work. What if I did this one? If x was 4 instead of 3, 4 plus 4 is 8, so that could work. So we could be doing whatever x is plus 4, because it worked on, change color, it worked here and it worked here. So let's check the next line and see if it worked there. If x is 5 plus 4, it equals 9. That works because 5 plus 4 is 9. 6 plus 4 is 10. 7 plus 4 is 11. So what we do is we kind of ponder through, and there could be, you're going to try a lot of different things on each row, and when you find what works for each of these rows, that's when you know you've found the equation. So the equation here is x, whatever x is, plus 4 equals y. And then we can just go ahead and plug it in all the way through. In this case, here x is 3. So I say 3 plus 4 equals, and it does equal 7. This one in this row is 4 plus 4 equals 8, because in this case x equals 4, so we put 4 in place of x. Then we have 5 plus 4 equals 9. 6 plus 4 equals 10. 7 plus 4 equals 11. And then it skipped a few, and skipped 8, skipped 9, but that's okay, because now that we know the equation for it, all we have to do is plug in for x 10 plus 4. So this missing number must be 14. Pretty. Okay, so the answer to that would be 14, and the equation we used to find it was x plus 4. So you just have to kind of puzzle through what are the possibilities for this equation in between? What gets us from here to there? Okay, and so this is one of those things that one we do is not going to have you ready for doing it on your own and going straight to a you do. So we've got about 3 we do's and 3 you do's to do together. After you've seen that many examples, it should start to click into place a little bit, hopefully. But like I said, be really patient with yourself. It's not one of those lessons that just comes to you real easily. For most people, it takes a little bit of practice. It takes a little bit of pondering to kind of get the hang of it. So here we go on our next example. Make sure to get this copied into your notes. And we're looking for what equation will get us from x being this to being that. From being this to that, this to that, this to that. And some of you might notice right away, you might start to see this right away if you look at this. And after a while, sometimes ones like these will really just pop into your head. You'll go, I see it right away. What can I do to 3 to make him become a 15? There's a couple of things I can do. It's moving upwards, so I can use addition. 3 plus 12. So if I said x plus 12 would be 15. Or x times 5, if I did multiply, would equal 15. That's times, would equal 15. So those are two possibilities. And so taking those possibilities, I'm going to look at the next line with the 4. Well, if the x is a 4, and I plugged in the 4 here, 4 plus 12 is 16, not 20. I need it to be 20. So now I've just eliminated that as a possibility. What about if I had, if I used x times 5 and x was 4? Let's see what I get. So I plug in for the x the 4, and I do 4 times 5. Well, 4 times 5 is 20. So it still could be, oh, I did not mean to do that. Okay, it still could be the x times 5 because it worked on this row and it worked on this row. So I'm going to check on the next row and make sure it works there. So if x times 5 is it, then if x is 5, 5 times 5 should be 25. And it is. So the equation that I must be working with here that gets me from x being this to y being this is going to be x times 5, or 5x, right? So if I plug in, remember this whole row is all the possibilities of x. So in this row only, the 3, x equals 3. In this row, x equals 4. In this row, x equals 5. So we're going to go ahead and go row by row. 3 times 5 does equal 15. 4 times 5 does equal 20. 5 times 5 does equal 25. 6 times 5 equals 30. And this last one, now that we know the key, it's sort of like finding the key to unlock the door. So now we know the key, the equation is x times 5. Then we can do 8 times 5 is 40, and we can find the missing amount. Okay, I do have another redo to do with you in a little bit, but I want to try 2 you-dos first before I kick it up one more spot. So this one is going to be similar to the last 2 that we did. So let's try this one. Let's see if you can see it. Here is, copy that down, and then here is what we're after. What can I do to 1 to get him to become a 7? What's the equation I use for that? And then compare the possibilities with what can I do to 2 to get him to become an 8. See if you can find what the equation is. Give it a shot and then push play when you think you've got it. All right, so let me see what you've got. We start with 1. How can I get a 1 to become a 7? I can multiply him by 7. X times 7 is a possibility. That would equal 7 if x is 1. I could also do x, whatever x is, in this case it's the 1, plus 6. So let me look at the next line and see which of these still stays true. If x times 7 here and x is 2, 2 times 7 is 14, not 8. So that doesn't work. Cross that off. If I had x plus 6 and x is 2, 2 plus 6 is 8. That does work. Try it on the next one. If x is 3, 3 plus 6 is 9, which is what we needed. 6 plus 6 is 12. So the equation, the key to it all, must be x plus 6 equals y. So that's the equation that we have. And if that's the case, when x is 1, it's 1 plus 6 equals 7. When x is 2, 2 plus 6 equals 8. When x is 3, 3 plus 6 equals 9. When x is 6, 6 plus 6 equals 12. And finally, when x is 9, 9 plus 6 equals 15 is our missing number there. All right, let's try another you-do. Go ahead and copy this down, and you have x being 1, 2, 5, and 7. When x is 1, y is 4. When x is 2, y is 8. When x is 5, y is 20. And if that's the case, then figure out the key so you can find out when x is 7, what is y. So go ahead and see, ponder it through a little bit, push pause, figure out what it is. All right, so you have an answer, hopefully. Let's see how you did. When I look at this, if x is 1, I did not mean to do that. If x is 1, then how can I get y to become a 4? What can I do to x to get him to a 4? I can multiply x times 4, so that's one possible option. X times 4 would equal 4 if x is 1. I could also add 3 to it, because 1 plus 3 is 4, so it could be x plus 3 is a possibility. So those two possible options I'm going to take to the next row, 2 and 8. If x is 2, 2 times 4 is 8. Ooh, that's good. And 2 plus 3 is 5, not 8. So it can't be that guy. Looks like it may very well be this guy, x times 4, but let's check the next line. If x is 5, 5 times 4 is 20. I think I found the key. X times 4, or if you put 4x, it's the same thing, right? So this is 1 times 4 equals 4, 2 times 4 equals 8, 5 times 4 equals 20, and 7 times 4 equals 28 is the one that we were missing. All right, this is the third and final we do, and the reason I set this one off aside is because this one kicks it up a little bit, kicks it up a notch just a bit. So there's two parts to this one. It's the equation isn't just a single item happening to it. There's two things happening to it. So let me show you how this one looks. Same idea. How do I get from 3 to an 8? Well, I can't do 3 times anything that gets me exactly at 8. One of the options is I can say, well, 3 plus 5 equals 8. So if x is 3, then that would work. But if you look at the next row, if x is 4, 4 plus 5 is not 11. So that eliminates that possibility. So what I wanted to show you is that there's more to this puzzle, and it can get pretty complex, but there's more to this puzzle than just either add or multiply or divide or subtract. It can be a couple of things. So one of the possibilities here is if I do 3 times 2 equals 6, and then I add 2 more to it, that equals 8. So that's one way I can puzzle my way to 8. So that was x times 2 plus 2. And so I'll try it and see if that works on the next one. If x is 4, then what I have is 4 times 2 plus 2. That's 8 plus 2 more is 10. And that doesn't work because I need it to be 11. So I can reverse that now. And I just have to keep, it's like a hypothesis, it's like science. You make a hypothesis, you try it, you adjust. And that's what we keep doing. So you're just not going to see it right away. People aren't going to see it right away. So I can try, let me try over here. What if I do 3 times 3, or whatever x is in this case, times 3? That would give me 9. And then to get it to 8, I would have to subtract 1. So if I did x times 3 minus 1, like I did there, will that work on the next row? If x is 4. So let's plug in 4 and try it. 4 times 3 minus 1. 4 times 3 is 12, and 12 minus 1 is 11. That one worked. But I don't want to be all comfortable with that yet. I'm going to try it on the next row. So again, I did this one, x times 3. I'm just going to make it 3x because it's the same thing, right? Minus 1. So 3x minus 1 if x in this case equals 5. If it works on this one, I'll feel pretty good. So we have 3 times 5 minus 1. 3 times 5 is 15. Subtract 1 is 14. Oh yeah, that's what I needed it to be. So the key must be 3x minus 1. So I'm going to go ahead and put 3x minus 1 on the line equals y. And now I can go through and say, all right, that's 3 times 3 minus 1. 9 minus 1 equals 8. The next row is 4 times 3 minus 1. 4 times 3 is 12, minus 1 is 11. The next row, kind of squashing it in there, huh? 5 times 3 minus 1. 5 times 3 is 15, minus 1 is 14. And the next row, 6 times 3 minus 1. 6 times 3 is 18, minus 1 equals 17. Looks like we found the proper key because it's worked on every one of those rows. So the last row is 7 times 3 minus 1. 7 times 3 is 21, minus 1. This answer must be 20. Those are a lot harder, and when you get to your challenge task, there's going to be some like that, but you get to work in collaborative groups for that, so that will be helpful to have another brain or two to ponder those through with. Okay, so now that you've seen that, and I realize this is not something you're going to be excellent at yet. It's definitely something that takes a lot of practice. And so you really might stumble through this, and you might get the right answer, and you might not get the right answer, and it's okay, because this just takes a lot of practice. Go ahead and give this one a try, though. It's okay to mess it up, but give it your best shot, and see if you can figure it out. Push play when you think you've got it. All right, let's see how you did. I've got 1 here that I need to change into a 3. So what equation here can force 1 to become a 3? I can do whatever x is plus 2 equals 3. That's one way I can do it. If I check it down here, if x is 2, 2 plus 2 equals 4, not 5. So it's not that. Nope. Scratch that out. I can do 1 times 2, but that's only going to give me 2, so I can add 1 more to it to get to the 3. So that would be the same as x, right, because x is 1 in this case, times 2 plus 1 is what I did here. So let's experiment in the next row and see if that works. You have x equals 2, so we'll do 2 times 2 is 4, plus that 1 more is 5. It worked here. Ooh, good, that might be it. Let me try it on the next row. If x is 3, 3 times 2 is 6, plus 1 more is 7. It's working. Okay, I think what the equation is this x times 2 plus 1, or let's rewrite it this way, 2x, because that's x times 2 or 2 times x, right? 2x. Goodness gracious, that's a terrible x. Sorry. Let me fix that. 2x plus 1 equals y. And as we go through, it should match all the way through if we're right. So 2 times, if x is 1, 2 times 1 is 2, plus 1 equals 3. Okay? That's that row. Now if x equals 2, we will plug in 2 for that. So 2 times 2, which is 4, plus 1 equals 5. Yes, that works. Then if x equals 3, we have 2 times 3, which is 6, plus 1 equals 7. If x is 4, then we have 2 times 4, which is 8, plus 1 equals 9. It's working. 2 times 5, which is 10, plus 1 equals 11. So finally, if x is 8, then it's 2 times 8, which is 16 plus 1 equals 17 was the answer. Now I know that's a tricky one, and it might have been difficult. Maybe you got it, maybe you didn't. If the first we do's, the first two we do's and the first two you do's, oh, this was you do number 3, sorry. If the first two we do's and the first two you do's were something that pretty well made sense, and you think you can handle those, then go ahead and get the closure, because the closure is going to be more like that. The challenge is going to have stuff like this, but you get to work with somebody. So if you think you can handle the closure, go ahead and get the closure and do those and bring them to me. If you need to review any part of this lesson, go ahead and rewind where you need to. If you need additional help after that, you can come see me and we can talk about it further. But again, be patient with yourself on this. It's not easy. It takes some time to get your brain used to it. So give your brain time.